Hello guys, I wanted to introduce you today to program and an add-in called Dynamo. Well, it is actually out in two versions. The first one is the free version that comes as an add-in with Revit, which is this one. And in this one you can manipulate your design in Revit. And this is the Dynamo Studio that Autodesk started building up. They finally decided to invest more in this product, which hopefully will be linked to more programs, more design programs from Autodesk. So the interface is almost the same. This one works on standalone license, so you can just use it. But the one in here, it only works with Revit. It works inside Revit. Actually, it works with robot structural analysis too. But many people are using that for Revit. So I've been looking for a few designs, and I can see that Dynamo is getting very famous with architects to do some designs. We'll have a look at some. Well, skip this one for now. This one too. Like, see this parametric design you can use in different projects. It's part of the design, you can duplicate it and you can have big project out of it. This one is parametric design too. So this one looks quite complicated. Oh, thank you. And this one is the most complicated. It's actually a design that makes these elements open and close according to the sun direction. So it will be offering more shade when the sun is going this way, so this part will be closed, these parts will be opened. When the sun is going from the other side, it will be closed from here and opened here. It offers more light and more shade at the same time. The point is, when you get to the point to use it for structure, I think, well, this is more complicated design made easy with Dynamo. So here we get to the structural design. You can even use it to design a rebar and to reinforce your structure with steel. Keep the current one, thank you. This is structure. Well, this is computational design. I think when I look at it, it's made by an architect. So it just gives the shape of the structure, but I'm pretty sure that these are not structure framing. So if you export this design to Autodesk Robot Structural Analysis, it will be quite a mess. This one too. So normally we use some profiles just to create the trusses. It's 3D truss. It's very easy to create when you do some special designs, but it is not structure. When I say it's not structure, I mean if you export it to structural analysis program, it will not recognize it as structure. It will be an architectural element. So here comes the power of Dynamo. We'll start by some few use of it. Actually, I wanted to say something else about Dynamo. I think many people are stepping back from using Dynamo and they are not really happy to use it, because when you look at it, look at this diagram, it sounds very complicated. When I first saw few diagrams, I was like, well, there is no way I'll do that. That might take more time than just designing it myself and creating elements and moving them around and do all that. But this is not very effective. I mean, if you want to design like this example, you'll never get to better result when you do it yourself. It needs to be computed and calculated and then give some branches to it, which is impossible to be done manually. But don't get confused with this. This is very easy. This is programming, but it is made easy by Dynamo, which is made mainly through connecting these functions with the lines, and we'll have practical example for that. So let's say we are here in a project. We'll see another thing to say, Dynamo is unitless. So Dynamo will be using the units that he gets from Revit. I'm more comfortable in working with, no, don't say this one, with meters. So I'll change the units here to decimal places. That will be enough for now. Yeah, don't mind the others. Well, let's say, okay, we'll build 2 walls. One here and another one just in front of it here. Well, you know what? Make it more complicated than that. I'll delete these. I build 2 walls like this, and the other one will be this one. So let's have a look at a 3D view of it. Well, this is unconnected and it's 8 meters. So if we have a look at our levels, we can add another one here, but let's say this is 4, this is 8, so this is level 3. We can say, okay, we'll copy this one, we'll put it on top of this, we'll change this one to 4 meters, and yeah, here we have it. Then we'll get back to the 3 designs. Let's get this one going from level 1 to level 2. And let's run our champion here, Dynamo. Let's say new. So basically Dynamo is based on nodes, which is this one. This is code block. It's a bit advanced, so maybe we'll get to this back on other classes. So you can use the nodes from the library, which is exactly here, and here is the geometry nodes, so you can use the arcs and bounding boxes, circles, curves, and then you can use whatever you want from these nodes. Again, the question is, what is this? Do I need to know all these nodes? It's thousands of nodes in here. So what's happening here? How am I going to manipulate this? With Revit, for example, I have specific nodes to use creating Revit elements, So this is the search tab. I've been watching some videos on YouTube, and some people are saying, well, if you know the node name, so you can just type it and you'll get the one you want. Actually, this is search tool, so you don't need to know the name. What you need to know is you need to know what you're looking for. So if you're looking for points, point on curve, so it will be point at parameter, point at segment length, end point, start point. All these are for the curves. So again, you can find them. So if we say curve and point, we get the same result. So it's mainly searching tool using words to search for whatever you're looking for. Let's say point, well, let's give it a try. Point on curve. See, it's almost the same thing. So there are a few differences, of course, but yeah, it's almost the same thing. So what we are going to do here using this Dynamo is, what I want to do first is try to catch a line on this top, on the top of this wall, and the line on the top of this wall, to use them as reference. So what I'm going to do is select edge, and here's it. We need two of this. This is first one. So here I'm going to select, the first one is the top line on this edge on the top of the wall. The second one is this edge on the top of the other wall. So here is the power. Here you can see Dynamo is offering us a 3D view of what is happening, and you can switch from nodes or diagram to 3D, and you can choose the view of your 3D, and then let's leave it there, get back to our nodes, and then okay. So what's going to happen next? What I want to do is I want to put some points on this line and some points on that line. So I'm going to search for points, or points on curves, and let's say curve points. It's just the order. So we say, okay, what we need is coordinate from point, not this one. It is equal segment length. I'll need this one. I'll need two of this one too. So here it says what we need to make this this one work here is to fit curve in here. We fit this curve in here, and we fit this curve in here. Let's actually create some more space here, and yeah, you can see already creates points with the default result, which is not quite what we really want. So we want to manipulate this and put the points in the places we want them to be. So the division is the distance we want to have between the points. So what we are looking for here is a slider, and the slider of integer. So we need two of these too. Actually, the difference between these two sliders is the number slider is going with the decimals, and the integer is going for numbers. So here we are going to decide how many points do we want. So we don't need this one because it will not be a good idea to use decimals in this number. Well, let's limit this one to 20, for example, and limit this one to 22. And yeah, here is it. So we'll say we want 12 points on this and 12 points on this. It is slider, so you still can change this number by sliding up and down and get the number you want. Then we'll link this one to this one. So how do we actually link them? We click on this out point and then click on this in point. Click on here and click on here. So what's happening? Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, okay, 11 because it's 12 distances, and it doesn't count the 2 limits because we will have special node to use for the 2 borders. And if we say, okay, this one we want it to be 7, so yeah, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 7, yeah, 6, 7, yeah, 6, 7, 1, 2, 3, 4, 5, 6, 7, and yeah, get back to 12 here. Okay, so we got points on there. What are we going to do next? So we want to join these points together with a line, and the line will be going from every point to the point in front of it to make kind of the structure. So what we are looking for here is line. That's easy. Line by point, and then let's say this list will be the start point and this list will be the end point. It's done, it's joining them, but these lines are crossing. Actually, the problem here is one of the lines, let's say this one starts from here to there, and this one starts from here to there, and so it's joining the first point to the first point and the end point to the end point. It's going with numbering them. So what we are going to do here is we need list reverse. Well, if you say list and keep looking, you'll find something called reverse. How do we use this one? We just put it in front of one of the lists because one of them is going on the wrong way. Link this one here, link this one here, and yeah, here's the magic. This is done. Let's see what's happening here. Here is it. It's done. Our structure is almost there. Let's keep doing this. So then what we need to do is put structure framing on every one of these lines. So let's say structural framing. Structural framing by type, we'll need this one, and then we'll need the beam by curve. Well, the beam by curve is our structure. The structural framing type is, we need this to fit it in here. So the choices we have here is the W310 by 38.7, which is actually, we don't have many choices here because if we get back to Revit structure, the only choice we have loaded on the project is this profile. If we want a different one, we can load a different one. Let's go to structural framing, steel and cast beam. Let's use this one. Load. So it's now loaded on the project. Now we can have really load, structural framing, steel, open. Okay, yeah, it's there, it's loaded. So we'll get back to here, and then here we'll have more choices. Let's say we'll use this one. We'll fit this one in the structure, and we'll fit this one in the curve, which is these lines. These lines are considered by Dynamo as curves. So a line or an arc or anything, it will be a curve. It's known as curve. Then we need to add a level. So and what level we want our structure to be is, let's say, level, and we'll get this one. So we want our structure to be on level 2. We'll fit this one in here, and yeah, here is it. It's done. Oh, because it's selected. I selected, so it's not running. Now it's running the automatic, and it's building our structure. Here is it. This is our structure. Actually, if you are trying to build this with the beam system, you'll need to build every one apart, because the beam system doesn't have an offset option. Like if you're just using a beam, what's this? Hello? Oh, yeah. So if you're using a beam, you'll have an start extension and extension. So yeah, you can manipulate it, but on the beam system you can do that. Then I'll show you really the power of this. So let's say we want this wall to be just 1 meter on the top of level 2. Apply this. Just a minute. Come on. Boom. Uh-oh, something is going wrong. Yeah, here's it. So if you change the level, Dynamo will automatically compute what's happening and then join this beam system to the top of the wall. See, it's automatically joined to it. So I'll get this one back to level 2, and then Come on, come on, come on. Boom. Oh. Something is going wrong here. Manually run. Well, select again and then ask it to run. Yeah, here is it. It's joining back. And then what I am going to show you next is the magic, which is really impossible to do that with the beam system. If we do this and then we run Dynamo again, it's taking time. Boom. This is what happens. This is, by the way, impossible to do with the beam system. So this is one of the uses. Hope you enjoy it and hope it shows how easy it is really to use Dynamo. So some people will be asking, so what if we want to join this end to this end? That's easy. Well, we need to type point in here, point curve, and we need an end point and start point. We need one here and one here. We need another end point and another start point. So we need one here and one here. Let's make sure it's end point on the top. No. Okay. Bring this one here and this one here. Then what we are going to need next is a joint list. So if we come back here and say list join, it will be this one. We need two of them. We'll bring this one in here, we'll bring this one in here, and then you can add the number of lists. Get this point, get this point, get this point. So what we need to feed in this one is the curves. So get this one, get this one. Feed this one in here, feed this one in here, and what's happening here is, so I stop the automatic run. If I run it now, we get these points too. And then here the other list, we need to add two others and join this list in here, this list in here, and this list in here. So what we are going to do is feed this one in here and feed this one now and start points, and then do run. Here we go, and yeah, it's done. So I have them all. Yeah, so what if we want this arc to be bigger? Let's say 35. And then we get back to our Dynamo and type run. Yeah, so I hope you get the point of it. So the point is, it is automatically calculated and updated itself to the design. So if you're making changes, don't be afraid, because it will be automatically linked to the design, and it doesn't need to be done again. This is how it works, and this is how simple it is. So please feel free to comment, to ask questions, and to share if you want. So I'll be very happy to answer your questions. If you like this, make sure you like it and you comment on it, so I can get your feedbacks and we'll get more in depth in using Dynamo. There is a lot of things going on online in using Dynamo in architecture, so I'll be more focusing on how to do the structural design with Dynamo, and yeah, hopefully that will be helpful to some people. Yeah, have fun, play with it, try to find out what you can find out yourself. If you can't find it, just contact me. Thank you, and see you next time.